Hello and welcome to Talk Julia. My name is David Amos.
And my name's Randy Davila.
Randy, today we thought we'd talk about plotting in Julia, which there's quite an ecosystem now that exists for doing plots in Julia. But I think kind of the basic one that everyone starts with, or at least that I know you and I started with, is the Plots.jl package.
Right, and this is an awesome package. It's really simple to use, and it makes plotting quick data visualization really easy. And I'm a big fan of it. So to kind of scroll around the documentation, you'll find that it's very well documented. So as we've mentioned before on the podcast, some of the packages in Julia haven't been documented as well as like we're used to or accustomed to from Python, but Plots.jl is definitely one of the top documented packages to me. It's very easy to read through. They give you plenty of examples to kind of just play with, tweak, and I really encourage our listeners to go and take a look at it. With that being said, I can show y'all some code real fast if I share my screen. Okay, so let's go ahead and just import the plotting package, so using plots. And what I think I want to do is maybe start with just the basic syntax of visualizing functions, right? So suppose we want to visualize maybe like the sign function, right? So I can define a domain using linRange. Okay, so linRange is a function that takes as input 3 arguments. The first argument is your starting point. Your second argument is where you want to end, so for example 2π, and your third argument is how many points you want in this range, so I'll just say 100 for now. So then I can call the plot function, just plot, and then pass in your x values, and then pass in your y values, which in this case would be sign broadcasted on domain. So this is the most basic way to plot X and Y arrays, right? So
yeah,
it's going to take a second to load the first time that you call these things, but it should pop up soon. So there we go. So this is the most basic form of the plot you'll see, and automatically it looks great to me, right? It looks, not to talk any like bad about matplotlib, but if you just do the very bare minimum with matplotlib in Python, it does not look this good. Right, yeah. So that's kind of nice. And one of the reasons why Plots.jl is out of the box nice is that it's really like a, what's the word that they use? It sits above other backends like GR, PyPlot, PGF PlotsX, or Plotly. And all of these are just available to the Plots.jl package. So for example, if you enjoy ggplot, or actually let me share my screen real fast so you can see this, you can set the themes using pkg.add plot themes, but once you do that, you will have access to a bunch of different styles for your plots. So for example, as I mentioned, ggplot's kind of a popular one in the R world. So if I go back to my code here, I can set my theme to be ggplot. So up here, underneath plots, I'm going to say theme, and then pass in the symbol ggplot2. Now if I run that cell, you'll see that it's a different style plot, which is kind of nice. And there's all sorts of ones. Let's just like, I'm just going to randomly pick one, maybe say lime. All right, let's see what that is. It's kind of high contrast image in front of me. And I think Dracula is a popular one. I spelled it wrong. No, I didn't. Maybe that's not currently available to me. I'm just going to try another one. Dal. Right? So each of these will have like different use cases, I suppose. Like if you're generating plots for like a paper or for like student notes that you hand out if you're a professor or something like that. But I'm going to go ahead and set it back to the default for now. Okay, so here's our basic plot. But as you can see, that there's no like X labels, Y labels. The legend is not non-descriptive, and I always tell my students that this is like terrible. Whenever you are making plots for other people, you need to describe them. So what I can do inside of the plots function is start to slowly add on attributes to this figure that we've made. So I can say like maybe X label is equal to maybe like time, seconds, maybe, I don't know, and then Y label equal to, I don't know, distance in meters. So I'm passing these strings in, and then I'll see like it automatically formats it pretty nice. Now, what about the legend here? So this is really easy. Just give it a label, and I'll give it the label, the string sign of X. And then run that cell again, and you'll see that it appears there. So what else can we do? Well, in textbooks, when you look at like the sine functions and the trig function, the cosine functions, oftentimes they'll be on the x-axis intervals of pi, right? Like pi over 2, pi, 2 pi, 3 pi over 2. So what we can do is we can set our x ticks by just simply typing x ticks inside of the plot function. And this argument, you can pass it different things, but my favorite to pass it is a tuple of arrays. So if I make a tuple of arrays, the first argument are the actual numerical values that you want to place the ticks at. So I could do, say 0, maybe pi over 2, and then maybe pi, maybe 3 pi over 2, and then finally 2 pi. Okay. Now, if I don't give this tuple a second argument, so it's just like parentheses around an array, and I run this, you'll see that on the x-axis, we have the numerical values that are in that array. However, if you want to format it and make it look nice, I'm just going to copy this array here. So just copy that, and then come over here and paste it is the second argument. And now I'm going to put strings around each of these values. And what this is going to do is it's going to replace those numerical values down below with these exact strings, which is kind of nice. Already it's starting to look like very textbook-esque, right?
Yeah.
Now, maybe I would like to now plot the cosine function as well. So the way to do this is by mutating the figure and calling the plot function again, but this time put the bang, the exclamation mark. And now I can just do domain, and now maybe cosine broadcasted on domain. And let's see what happens. Oh, the label is not descriptive. That's bad. So I need to give it the label cosine. Cosine of x, like that. But now my legend is kind of overlaying on the cosine. See that? So what we can do is like in either one of these functions, plot or plot bang, we can specify where the legend is going to go with the legend argument. So legend, and you pass this a symbol of where you want it to be. So maybe like top left, I think is one. So I come back up here. Now it's over on the top left. So I have to guess what the center one is going to be. Top center, maybe? I have no idea. I never put it in the center, so I don't know. That didn't work. Oh, you know where the best place to put it, though? Right here.
Where?
Bottom left.
Bottom left, yeah.
Alright. So, I think that's the best place to put the guy. Oh, I almost forgot we don't have a title. So, to put a title, we just have to pass it the title keyword argument, basic trig plots or something like that. And then we get something like that. Okay, that's a nice looking plot to me.
Yeah.
So this is pretty useful. Now, if we wanted to maybe like add points to this, we can use the scatter function. So scatter on top of this this figure that we've made. However, I think I'm going to wait to do scatter until I show everyone how to maybe add, like, make two figures instead of just one figure. Okay, so now in the same cell, I'm going to say, okay, this guy here, I'm going to give that maybe P1. So I'm going to assign that to a variable. And then this one here, P2, assign that to a variable. But now I'm going to get rid of this bang function here, bang in the name. And then I'm going to call the plot function, but now I can pass in P1 and P2. However, now I have to specify a layout. So how do I want these things to be laid out? Maybe in a 1x2 grid. Let me see that. Oh, and now the the title has been assigned to P2, so it only appears right there. So maybe I could,
that's where you put it.
Yeah, so maybe I can just say cosine plot there, and then go up to here, and then say maybe sine plot. And you can see the differences in the plots where on the sine plot we have the nice X ticks, but in the cosine plot, not so much. And the legend is like all over the place, right? But this is, to me, very natural to do. The way that it feels kind of stacking these together is nice. Especially with this, plotting these two figures next to each other. In Python with matplotlib, you have to do like the subplots method, and it's not as clean to me, right? It's like you're dealing with an object instead of taking two figures and passing them into a function, which to me feels a little bit easier. So, okay, what's up next? Well, next I'm going to show everyone how to plot scatter plots, because that's kind of a very common thing to do. And to do this, I'm going to use the R datasets package. And then I'm going to look at this famous iris dataset by calling the R datasets dataset function. Pass in your first argument to this is the name of the package where the dataset is coming from. And then the second argument is the name of the data that you want. Now, this is going to load in the data as a data frame. So in order to manipulate and view this data, I'm going to have to also import dataframes.jl. And then I can just maybe look at like the first few rows of this thing, this iris dataset, by calling the first function. Oh, data frames, not data frame. Okay, so we see that we have this data here. Now, this dataset consists of 3 different species of flowers, 4 different measurements, and I would like to visualize in 2 dimensions this data. So the way that we can do this is by maybe calling the scatter function from Plots.jl, and for the x values, I'm going to pass in maybe the sepal length of this iris dataset, and then for the y values, I'll pass the sepal width, like that. And then maybe I'll just plot that. What does that look like? Okay, so we see a messy looking plot to me. On the x-axis, sepal length, y-axis, sepal width. There's only one colored marker. It looks like these are all the same species. I can't distinguish the 3 different species at all. So what I can do is maybe, well, first off, I need to give my axes labels. So I'll say x label equal to sepal length, and that is in centimeters. Y label equal to sepal width, also in centimeters. And then I can pass in this group keyword. So group will be the species, right? So if I pass in the species column from that data frame, what's going to happen? Oh, nice. So that's one really cool feature about plotting with Plots.jl and mixing this with dataframes.jl is that you can automatically generate a legend and the appropriate names based off of that column of data, which is really nice. These colors are kind of gross to me, though. Like, I don't know what it is about the red and the green mixing together for the Versi color and the Virginica. I'd like to pick better colors. So what I can do is pass in, I think it's marker color. Okay. And if I have to share my screen again, and we'll provide links to these links here because they're not that easy to find. Like, they're easy to find, but basically there are. If you go into the documentation for Plots.jl, you can find all of the named colors and all of the types of markers that you can use. So in front of me, I have just a page of all the possible colors that are kind of native to Plots.jl that you can just pass in as like a string or as a Julia symbol. So my favorite colors, I think, are dark sea green or light sea green, magenta, and I don't know, fire brick. I don't know. So, okay. Now let's make sure that I have my code up again. I think the keyword argument is marker color. So hopefully this works. So fire brick as a symbol, light sea green as a symbol, and magenta as a symbol. There it goes. Okay. So what I passed in now to the scatter function was the keyword marker color equal to a row array, a row vector of symbols. So there's 3 different species, 3 different symbols that you pass in. It's kind of nice. It's a little bright for me, so maybe what I want to do above this is maybe change my theme to ggplot2. All right, so looks pretty nice to me. What else can I do? Marker size. Maybe I can make this like a 3rd dimension in a sense. So I could do like iris dot petal width. And you can see
you got maker size instead of marker size.
Oh, okay. Surprised I didn't give an error. Oh, they disappeared.
Yeah.
So maybe what I can do is I can maybe times this with 10, see what happens. Okay. Well, they're kind of overlapping with each other. It's hard to see. So what I can now do is pass in alpha. So this is how transparent the markers are going to be.
Yeah.
0.25 maybe. Okay, that's like a cool looking plot, I guess. So, yeah, I can't emphasize enough how awesome it is to work with plotting data frame type data using Plots.jl. Because of that group keyword, that just makes life a lot easier for me, especially coming from Python, coming from a Python background.
Yeah, well, I mean, if you're using raw matplotlib, certainly things are more complicated. If you're using the pandas plotting functions, I think you get a lot of similarity with what you've got.
Right, there is some similarity there. It's not as pretty looking to me, but there is similarity.
Yeah, but I like the API for the Julia plot function. Is really easy to just kind of guess at what things should be.
Yeah.
and it ends up being, I don't know, it's just a little bit easier, I think, to wrap my head around exactly what's going on. There was a really great example in the last episode I did with Bogomil Kaminsky, where he was showing a plot from his book Julia for Data Analysis, which is going to have some of this visualization and stuff in it. But he was showing a fairly complex plot that shows up in at the introduction or the first chapter of his book, and he showed the code for it, and it's just using Plots.jl, and he had the data in like a string, basically as like a CSV file, but like in a string, in there, and the vast majority of the, you know, what was in the code file was just the data. So the plot itself was like, I don't know, 15 lines of code or something like that, and you know, it was a nice looking plot. It was actually two plots side by side using the layout and everything. So yeah, super powerful, super easy. And I guess the nice thing about it too is it, you know, talking about like the multiple dispatch system and everything, is, you know, the fact that like you don't have to have a special API to deal with the data frames. You just treat it like any other object you would pass into the plotting function, and it just gets taken care of, because of, you know, the way the multiple dispatch aids and all of that and everything. So that's something else that's really nice about it, is, you know, a data frame is basically just like a two-dimensional array. So and a column in a data frame is just a vector, and you know, there's no special, you know, you don't have to do anything special with them to like convert them to like NumPy arrays, or like
Right,
you might have to do for like in
exactly.
Python or anything. It just knows how to handle all of that. So that's something else that I really like about Plots.jl and just, you know, the Julia ecosystem. Yeah, and so Plots.jl isn't the only package that exists for doing plotting in Julia. There's actually, at this point, there's several different packages that exist. There's quite a wide ecosystem. And there's an article, it's a little dated at this point. It's from October of 2020, by Emmett Boudreau. Article is called Julia Visualization Libraries, which is best. And like I said, it's a little bit dated, but it does have an overview of some of the things, some of the more popular ones. So it starts with Plots.jl, like we've talked about so far, and then mentions GadFly.jl. So Emmett says that Gadfly is his favorite, or at least it was in October of 2020. I don't know if that's changed or not, but it's a little bit different. So Gadfly is written in pure Julia, just like Plots.jl is, but it renders a lot faster, according to Emmett, and also includes some different like interactive kind of stuff. So GadFly.jl is largely based on the ggplot2 library for R. So the interface is going to be a little bit, you know, more in line with that. So if you are familiar with ggplot2 and are used to using that, then the API might come a little bit more naturally to you. It works with Jupyter notebooks and has tight integration with dataframes.jl, so has all that stuff. But it's also got different interactivity, so you can do things like panning and zooming, and toggling, and has a large number of different plot types. So you still have a plot function. Looking at, you know, in the docs examples of plotting, still have a plot function, and in some cases it actually looks pretty similar to Plots.jl. Some things are a little bit different. So you can give it, for example, a vector of functions, and then just give it the limits, like the lower and upper limits on the x-axis that you want to plot. So this is one way to plot both sine and cosine on the same plot in just a single line, as opposed to using like the plot function to plot sine and then using the plot bang to plot cosine on top of it. So with Gadfly, you can do that in just a single line. And this example here actually also shows a different approach to stacking plots to make, you know, multiple plots in the same figure. So here you've got three different plots, P1, P2, and P3. And then you can stack them using the H stack, the horizontal stack function, which is just a base Julia function. Gadfly may have made their own, method on H stack here to handle plot objects, but yeah, he uses H stack, and then you've got the three plots in a row there. And to add to a plot using Gadfly, this is another kind of difference between Plots.jl and Gadfly, is you use the push bang function here. So if you have a plot P, then push bang and then pass P as the first argument, and then add stuff to it that way. So you can build up plots using this push like that.
Wow, looking at the documentation, they just plot the iris dataset to the completely. There's so many different examples of plotting this iris dataset that I'm looking at on my screen, and I like it. I've actually never used GadFly.jl.
What are you looking at?
I'm looking at...
Or here, why don't you just share your screen?
Oh, yeah. So here we have iris dataset loaded using our datasets, just like I did a moment ago.
Mm-hmm.
But then look at this plot right here, this horizontal plot. I don't understand exactly what's happening with the geom.
It stands for geometry. You can do these subplots and different stuff using these different geometries.
Oh, I see. I need to actually read. It tells me right here. So then, okay, going down some further, another plot of the iris dataset, but now looking at a nice V stack of these things here.
Yeah.
Just looks really nice to me. And then here they're combining this this grid stack, and I like the automatic sizing that I see in front of me generated by these positional arguments inside of the Gadfly plot functions.
Yeah. Yeah, so it's a different approach to combining plots and everything.
But as you can see, here's another iris plot. This is a different type of plot. Yeah, this is cool. I'm really into this.
I've seen a lot of people say that Gadfly is one of their favorite plotting libraries. But there's even more than just Gadfly. So Gadfly is a good alternative. I think specifically for statistical type stuff, Gadfly is going to be.
I just pulled that up.
Yeah,
that's really awesome. These density plots. There's a lot of keyword arguments here, but still, they look nice, and that's especially for generating figures for papers or student notes or things like that. This seems pretty good.
Yeah, being able to make something that looks very nice and professional quality without having to do too much fiddling with with all that stuff is always a big plus.
Yeah, this is okay. This is very similar to the types of plots I see my colleague Catherine generate with R. So as you were mentioning earlier,
yeah.
This is kind of built off of R, and it makes sense now that I'm looking at it. What are these jitter plots? I don't know what that is.
Yeah, it's meant to be similar to the ggplot2 package in R. So
I guess that's what I'll be playing with later today. It looks pretty interesting.
So another option is the VegaLite package, VegaLite.jl. Similar to ggplot2, it's got this it uses this traditional grammar of graphics API. I think that's what the GG in ggplot2 stands for, grammar of graphics. This example shows you an example of a scatter plot where you're taking a car's data set and you're actually piping it into this macro. So, kind of highlighting different parts of the Julia language being used for different things. And VegaLite has a bunch of examples of different bar charts. So this @VL plot is the VegaLite plot. And then you say, okay, I want a bar. But what's interesting is you take your data and you actually use the pipe operator to pipe it into this plot thing. So again, kind of a little bit different approach.
I also like that it seems to be that there are some good toy datasets inside of VegaDatasets.jl.
Yeah. Yeah, here's a barley dataset. So VegaLite is another option, and then there's also Makie, which I've not used before. I haven't used any of these personally except for Plots.jl. But Makie is a whole visualization ecosystem. It's supposed to have high performance and is extensible, and as you can see, it can be used for making like animations. So if you're watching this on YouTube, they've got a you'll see on the screen a animation of the Lorenz attractor.
Plots.jl also has that, but it doesn't rotate. Like that's rotating in front of me.
Yeah, with Makie, so it's almost from what I've noticed looking through the documentation and everything. So in addition to having like animations like you would think of for like animating a plot, there's also like a camera that you can animate. So you can actually move the camera around, and that'll move like the view you have of different things. So it's actually, you can make pretty complex and involved animations with Makie. I mean, you could zoom in into this and like fly around the graph if you wanted to, and it's got. I felt like the documentation was pretty good. There's like a basic tutorial. We're learning the different basics of Makie, and it's got it's a very different approach than just Plots.jl. So really, the best thing I think to look at. I mean, if you want to learn it, I think going through this basic tutorial is a good first step. But in the documentation, there is see, not the API reference. Where is it? Examples. Here we go. There's a plotting under examples, and then plotting functions. There's examples of all the different plotting functions that they have. So there's this AB line function where you can have different types of lines on there. They're in alphabetical order, so it may not make the most sense. Just go through it if you're like learning it, but to make it easy to find, there's an arrows function that can be used to make these arrow plots and things like that, sort of like vector field diagrams and all sorts of stuff. You can do 3D plots. They've got band, different kinds of bar plots, box plots. They've pretty much got every kind of plot you would think of. Some pretty cool looking density plots. There's also, so the Makie ecosystem, so it's got 4 different backends. And so there's the GL Makie, the Cairo Makie, WGL Makie, and then this RPR Makie, which is Radeon Pro Render, that does ray tracing for Makie scenes. So this is experimental, but you can see some pretty interesting stuff here. So this is kind of what you see a lot of traditional ray tracing things. You've got spheres, shadows, and things like that. So that's kind of interesting. You can take your Makie plots and you can do ray tracing in them and get some really interesting looking like topographical maps.
Interesting. It works for both AMD and so like AMD Radeon GPUs, but also works for NVIDIA GPUs.
Yeah. I think this is still experimental. So it's not like prime time yet, but yeah, you can do all sorts of interesting things. It's also got interactivity. So here you can see where they've got the ray tracing, and then they've got these different interactive things they're using to kind of change aspects of what's going on in the plot. And you can do animations with it, with the ray tracing. So here's an interesting one where you've actually got so the code is quite involved, but they've plotted this very realistic looking Lego figure using Makie and this ray tracing engine, and then animated it and made it walk across the screen. So you can do like really powerful kind of stuff with this, the ray tracing and the Makie. And the last thing I want to mention, there's so much more to talk about. I mean, there's GeoMakie for doing geographic plotting. VegaLite has geographic plotting. I think Plots.jl and everything can all do the geographic type stuff with it. Graph Makie for plotting graphs, and in Plots.jl you have like the graph recipes package for plotting graphs. There's a graph plot for plotting graphs. All sorts of different stuff in here, but one that I wanted to mention that I thought was really cool is this AlgebraOfGraphics.jl. So this is, again, kind of going back to this, grammar of graphics style from like ggplot2. This is, you can define an algebra of graphics based on a few simple building blocks that can be combined using the plus and the multiplication operators. Here's an example of making a frequency plot using the Palmer penguins data set. So you can take the data from the penguins and you use this multiplication operator, and there's this frequency function that you multiply that by, and then this mapping what you're going to map the frequency to. So the species, that's basically going to set what's on your x-axis, and the frequency takes the count of that. So you basically take your data, you can multiply it by frequency and multiply it by mapping. So again, this goes back to this idea of like this algebra of graphics. So this is a very different way of looking at plots again.
Very different.
Yeah. And, makes for some like very concise code, but may not be the easiest to like reason about the first time you see it. But I thought it was a really interesting approach, kind of a neat thing to look at and maybe play around with. Maybe there's something there that makes a lot of sense for you. And then the very last thing that I want to mention is just, where to go to learn more about visualization in Julia and get help with visualization in Julia. So the Julia discourse has a visualization category, and it's quite active, and there's all sorts of questions and discussion going on, all sorts of discussions about visualization, graphics, images, plotting, etc. And they've got links here to different GitHub organizations that you can see for different resources there. But yeah, highly active and lots of discussion going on there. That's a great place to go to get some help or to just learn more about visualization in Julia. Well, I think we covered a lot of ground today, Randy.
Yeah.
Now I think each of us have a lot of things that we probably want to go play around with and take a look at.
For sure. Yeah, Gadfly looks pretty awesome to me, and I think it would impress my my statistician colleagues that are always griping about like Python plots.
Awesome. Well, thanks for hanging out and talking Julia with me.
All right. See y'all.
All right. Bye.